Well, so we have designed our high pass filter. Okay, now high pass filter as a passive high pass filter. Then we saw our design of a active high pass filter. Now, first of all, high pass filter also have this gradual cutoff problem. So we can actually mitigate that using higher order. So in the last video we saw first order high pass filter, but we can actually add another capacitor, a reactive component, to increase the order of the filter, so make it second order filter. But as we increase the order of the filter, it poses another problem, that is the gain actually decreases. Okay, the gain as decreases. So we can actually also mitigate this problem by using an op-amp, okay, which will amplify my signal, so which will solve this attenuation problem. But we saw for a high pass problem, high pass filter, is that when we are actually doing this using an op-amp to amplify my signal, there is a problem with the high frequency components. Okay, op-amp cannot actually amplify my all the frequency components similarly. Okay, the high frequency components, it cannot amplify the way we want. So this is a problem. So when we have very high frequency component like megahertz, in the megahertz region, okay, we cannot actually use these active filters anymore. We have to use passive filter for high frequency components. Okay, so for high frequency high pass filter, when we have very high frequency components, we'll use the passive filters. Now we have shown you that how to use a RC filters. So we normally use RC filters for less than 100 kilohertz. So when we have greater than that greater than 100 kilohertz, we use a RLC filter. Now RLC filters is actually beyond the scope of our discussion here in this filter design. So so there is, you can see that there is actually a trade-off between which kinds of filter to use. It depends on the situation, what you want, and which gives you the better result. So let's take a look at the difference between active filter and passive filter now. Okay, so let's see, I have active, okay, and here I have passive. Okay, so active filters, okay, so active filters, sorry, so active filters contain op-amp, they contain resistors and the capacitor. Okay, understand, remember that although resistor and capacitor is not actually an active component, but an active filter can have resistor and capacitor, but it must not have inductor. When I have an inductor, it becomes a passive. Okay, when I have an inductor, it becomes a passive filter. Okay, so it has R, L, C. Okay, now the problem with op-amp active filter, the problem with active filter is that it has a finite frequency response. It has a finite frequency response. Okay, finite frequency response. But our passive filters does not have that kind of problem. So it has a infinite. So we can say theoretically it has a infinite frequency response. Okay, now there are some other issues that, although not the most important, that for example the circuit is actually complex circuit for so we have used op-amp, so circuit becomes much more complex, much more bulky, so it becomes much more costly. Okay, and it is actually opposite, passive filters is much more simple. But when we are using when we are using an RLC, okay, RLC filter, it becomes much bulky, it's very bulky. Why is that? Because inductor actually makes in the presence of inductor makes that filter much more bulky. So if we have time, we'll actually discuss about the RLC filter in the end. Okay, now there are some other parameters like active filters, okay, have much better response. Okay, it has much better response. Okay, better response compared to these passive filters. Compared to passive filters, active filters actually provide a much better response, and it does active filters does not actually suffer from the okay, better response. It does not suffer from the attenuation problem. Attenuation problem. Okay, no attenuation problem. Okay, so active filters does not actually suffer from the attenuation problem, but passive filter has that kind of problem. And there is another thing like the quality Q factor. We'll discuss a little bit later. The quality factor of active filters is much higher compared to the passive filters. Okay, so remember this difference between an active filter and passive filter, and there can be some questions that in this situation, given a situation, what kind of filter is the best to use. Okay, so prepare yourselves in that way.